In the previous video, we looked at the concept of the z-score and how we could take points along any normal distribution, compare them to compare the deviation of that point from the mean to the standard deviation and come up with a z-score. And so in summary, we said, this 72 was half a standard deviation above the mean for males. It had a different it was 2 standard deviations above the mean for the females, and I think it was 3 1/3 for the synchronized swimmers. The z-score is related to another concept that we're going to draw on, and that is of the standard normal probability distribution. So let's build a distribution, and let's have it have a mean of 0. Okay, so I've kind of shifted the number line, and there's a mean of 0 and a standard deviation of 1. Okay, and this is going to bring with it some very useful properties because we're being so standard with it. So the mean of 0 and the standard deviation of 1. And so what that means is that if we were to plot various points along that, so let's say we plot the point 2 or the value 2 on it. Well, that value is 2 standard deviations above the mean. If you recall from our previous video, that is for females, that was the height of 72 inches was 2 standard deviations above the mean. And so in some sense, you could think of the standard normal distribution here as being a distribution where we can plot z-scores out on. And so we could also plot a value at 0.5, and that would be associated with the standard deviation, or sorry, the z-score of a male at 72 inches. So there's a direct connection between the standard normal probability distribution and those z-scores that we just calculated. Now, this can be incredibly useful when we turn to trying to talk about probabilities between certain ranges. So for instance, if we wanted to know what is the likelihood that a male is between 70 and 72 inches, right? That would be a range. We could figure that out. Let me actually flip ahead here. So the likelihood that a male is between 70 and 72 inches is this shaded region here, right? And as we've talked about, to do that, we would need to figure out the area under that curve. Now, the helpful thing here is we can turn to the standard normal probability distribution with the mean 0 and the standard deviation of 1. And what we know is this. Let me clean that up a little bit so we don't get too confused. So the standard deviation is 1 here. The relationship is the same. So if I draw a line in here at 0.5, so the share of the area here between 0 and 0.5 standard deviations is the same as from 70 to 72, because that is also 0.5 standard deviations. So this is going to be a helpful trick because, again, if we wanted to find the area under this curve, we would have to integrate over the equation for that particular normal distribution. However, if we rely on the idea that these are going to give us the same area, right? So underneath both of these, obviously one is enlarged, but the area under this whole curve, right? This whole area is 100%, and likewise, this whole area is 100%. And so what we're really interested in is that shaded red area, and that's going to be the same share of the 100% in both cases. Furthermore, if we wanted to look at, let's say the share or the likelihood of a female being from 65 to 72 inches, that would be the same as from 0 to 2 standard deviations, right? I'm getting a lot of different colors mixed up here, but that shade is the same. That shading is the same area as this shading. So we can transform any of these points, or any of these distributions can be transformed into the normal distribution. And so we can use results from the standard normal distribution, they can be transformed to the standard normal distribution. And we can use results from this standard normal distribution to calculate areas and know that that's going to be the equivalent percentage area. So we can rely upon what we would find if we integrated this whole, any points within the standard normal distribution. Now, we would still have to go through the painstaking process of integrating that gross normal formula, except that somebody has already done it for us. Okay, so every possible kind of situation has been worked out with the standard normal and put into a nice clean chart for us. So all we need to do, if again you were curious about the likelihood of being between 65 and 72 for a female adult, you would then need to just look at the likelihood of being between 0 and 2 on the standard normal. And that is readily available in the back of your text, online, anywhere. It's posted on Canvas as a Z-table. And it's also shown here. So this Z-table contains basically any combination of, or we can pull from this any relationship or percentage that we want to pull as far as the likelihood based on the Z distribution or the standard normal distribution. Sometimes we refer to the standard normal as just the Z distribution. And so now we don't have to go through that process of adding up the whole complicated formula there, or integrating. And so this is kind of the crux of why we go through this whole normal distribution, standard normal distribution and the Z-score, is because it allows us to rely upon this type of table to quickly answer the questions that we're most interested in. So I'll be back with another video and we'll walk through some examples and learn and talk about how to use this table, because it does take a little bit of practice to get your head wrapped around what we're actually trying to accomplish.